Hey, g'day, it's Prezzo. Thanks for stopping by. I'm working on the Stuart Turner 10H engine again today. This is episode 6 and there is a playlist and the link's up above there now. In today's episode I'm going to make the piston for the engine, we're going to make the oilers, I'm going to get rid of that horrible sideways S that was cast into the steam chest cover and supplied by mistake, and there's a few sealing glands and so on to make. So let's get into it. Now I want to go ahead and make 3 of these little tiny oilers for the Stuart Turner 10 engine. This one here came out of my Stuart Turner number 8 and this was supplied with the kit. I didn't have to machine these, but I want to duplicate exactly the same size oiler for the Stuart Turner number 10. Now these are tiny, they're just over 11 millimeters long or 7/16 of an inch. There's a 5 BA thread on the end and there's a little bit of detail in it. There's a sort of a rim around the top here, and there's a little groove just above the thread. Now you could make these with regular turning tools in the lathe. Probably you'd use a couple of form tools to do most of this, and making one would be fairly straightforward, but trying to get 3 to look identical is a bit more of a challenge. Now what I've decided to do is use my Tornado copying attachment to do these, and I've made this yellow template here from acrylic. Now this has been laser cut, and the little bit of detail on the end there is just half the profile of the one that I showed you for the Stuart Turner number 8. Now you can make these templates from laser cut acrylic, or you can just cut them out by hand and file them. This one here was for a model aircraft engine that I made. This one was easy. This one here is about as small as you could possibly go with this type of work. And the problem here is that the turning tool has a slight radius on the end, or actually quite a large radius, and the little stylus here is identical in shape to the turning tool. So as long as you trace around the template there, it would duplicate that shape, but the little details in the laser cut template here are probably smaller than the radius of the tip of the tool. But it does work. I've already made one. I'll make this one now. Now this stock here is oversized. It would be better if you use some brass stock that was closer to the size that you need, but it does work, so I'll go ahead and make one, and then we can add them to the engine. Right, that's what it looks like after the first pass. Now this is still 2 millimeters oversized on diameter, and I've set the DRO to give me a diameter here of 3.18 millimeters or 1/8 of an inch. So I'm going to take like 0.5 millimeter passes till we get down to this correct diameter, which is going to be threaded. Alright, so there's a little thread there. I'm going to part this off now, and then we can flip it around the collet and drill out the bore where the oil reservoir will. Yeah, like I say, tiny. Alright, just pop these in the collet and finish off the other end. Okay, there's our replica. I'll get the other two done and then we'll get them assembled. Okay, I think it's time to fix up this sideways S on the steam chest cover. So I'm working on a small CNC mill today. I've got a sacrificial steel plate in the vise here, 6mm thick, and I've soft soldered a piece of 2mm thick brass to the top of that. And I'm going to cut out a circular disc with the S shape inside that, and I'm using a 1/16 inch end mill to do that. That's the biggest I could go and still be able to get the shape of the S that I wanted. And then we'll take that little coin-sized disc out and it will be going into this spot here. We'll have to mill out the S that's already there and it'll just pop it back in place. Okay, it's turned out pretty good, except I didn't do a very good job of centering this on the stock, but there is enough material to do the outer profile. Okay, I think that's exposed as solder underneath there, but I'm not entirely happy about that inside profile. I might need to run another pass around the inside of that. It looks too thick around the side here. So I'll go back to the smaller cutter, just clean up the inside there. Alright, this is one of the sad realities of making small parts on a CNC milling machine. It almost never goes right the first time round. And this S here is the first one I did that I showed you on camera. When I took it out of the vise and had a close look, I realized that the outline, the outer profile of the letter S itself had defects. And I think what had happened was I was getting some tool deflection and I did not run a cleanup pass. So I just machined out the pocket and left it at that. And the tool deflection was biting in and digging in two locations, here and here. And it just wasn't good enough. So I did it all again. So second time around, I did essentially the same machining process, but I left a 0.2mm machining allowance around the letter S itself and this inner profile here, and then I ran a second pass and took that off as a finished pass. So when I went around the outline of the S, it did it as a continuous machining path, and that just meant that we're getting sort of consistent tool deflection and you didn't notice those little defects. So I think this one is way better. I'm going to bead blast this now, and that's going to smooth off the sharp corners and sharp edges. It'll get rid of that pattern in the bottom there, and it'll look like a casting. And then I'll desolder this one, and this is the one that we'll put in the steam chest cover. Alright, I'm going to be back in a minute. Okay, there it is after bead blasting, and what it does is it softens the look and it gets rid of all the machining marks in the bottom of the pocket. It softens the outer edges of the profile as well, and it just looks like a casting. So I'm going to desolder this now and then we'll cut the pocket in the steam chest cover. Okay, let's make this S go away. Okay, now I know that's going to be undersized, so I deliberately cut that about 0.2 smaller than the disc, and I want to measure that, and then I'll just take another pass around the inside until I can get this to be a snug fit. Now it's meant to be 18.6. $18.52. So I'm going to take another couple of passes around the inside and then this will eventually probably just get stuck in with Loctite or JB Weld or something like that. Alrighty, will it fit? Oh yes. Now I've left the brass disc slightly proud of the surface of the casting for the steam chest cover, so it's about 0.25 millimeters thicker or higher than the outer surface, which is the cast iron. And later on, after I've done all the finishing on the engine, like the powder coating of the steam chest cover, we'll just pop that part in. Now I'm not sure yet whether I'm just going to leave it with the brass finish or try and put some powder coat in the bottom. I think just like that looks great. So yeah, that's a win. Didn't ruin it. The next part I want to make for the engine is the piston, and I can't catch a break here. Every time I turn the camera on it starts to rain. It's rained here almost non-stop for the last 2 weeks, and it gets quite annoying, but you just have to listen hard. So this is the material that was supplied in the kit for the piston. Now it looks like brass. Now brass is not the correct material for making a piston for a steam engine. It's okay if you're going to run it on air, but if you want to run it on steam, the heat and the steam, the moisture content of the steam will take the zinc out of the copper alloy, and you're left with a material that's porous and brittle. So it's called de-zincification, and it's quite common on brass fittings on steam engines. So a better option would be a cast iron piston in a cast iron bore with cast iron rings. And you would need lubricating oil, of course, if you're going to use an engine with a cast iron piston. Now, I don't want to go to that much trouble, but I do have some bronze rod. This is the correct diameter. So I'll make the piston from bronze, and we'll put a packing ring in the center of the piston, and I'll machine this down close to the correct size and then fit the piston rod, and then we'll check the piston rod for run out. If it looks like there's a bit of run out there, we'll finish the piston on the rod. Just off camera, I ran a 5BA bottom tap all the way up inside the bore there, and just using the 3-corner scraper I took out a little bit of the thread in the end of that bore there. And the reason for that is that our piston rod is 5/32 of an inch diameter and a 5BA thread on the end, which is roughly 1/8 of an inch. So there is a shoulder there, and we want that shoulder to run up hard against the face of the piston there. And I'll show you why. So I'll run the piston rod in almost all the way, and just imagine it got tight at that point, and we'll run the lathe. And you see there's some run out there, which is basically the wobble in the thread. But when we run that in hard and run the shoulder right up against the face of the piston, it should be better. Now there is a tiny bit of run out there still, but I don't think it's worth holding it by the piston rod and trying to machine the piston, because you're going to get chatter. So at the end of the day, I think that run out there will be taken care of by the clearance in the piston. So I'll go ahead and machine this to 19.04. The bore of the cylinder is 19.05, and then I'll put the grooves in for the packing and part it off. So it's a fairly straightforward part. Okay, that's pretty much size on size, so I do need some clearance there. Take a 1/2 thou off that. I'm going to leave it there. I'll just hit that with some Scotch-Brite. I think that's good. I can sort of feel it going on, but it's catching on something. There could be a burr inside there where I machined that pocket. So I'll just leave it there. I think that's right. That's it. A bit of oil in the packing in there, that'll be fine. Alright, so there's that piston. That groove in the center there is 2 millimeters wide, 2 millimeters deep, and we'll be filling that with a graphited yarn as a sort of a soft packing. But I need to clean up the back face of the piston there now and get rid of that machining mark. That just needs a very light cut. Okay, happy with that fit there. There was a very small burr just where that pocket was put in the end of the cylinder there, and I just took that out with a bit of emery, and now it feels very nice. This is the bottom cylinder cover from the main steam cylinder, and this hole in the center here is where the piston rod fits through. It needs to be sealed so that it can still slide but it won't leak steam. So the part that I've just made there is a threaded gland, and this will compress the soft packing in the hole in the bottom of that steam cylinder cover. And what I've done there is I've left a fairly big countersink in the center, and what that will do is it'll compress the packing against the piston rod. So the last thing to be done on this now is to cut a series of 6 grooves or slots around the outer edge of that, just so you can get like a spanner in there to tighten it up and make it seal against the steam once we've got the engine assembled and running. I screwed that brass part into a threaded mandrel, and that's sitting in the hex collet block, so I can go ahead and cut those 6 slots. And the slots are just so you can grab hold of that part and tighten it up, because we'll be up inside the trunk guide of the steam engine when it's fitted. And many years ago I made up a whole bunch of these little threaded mandrels. Now they've got, some of them have got female threads one end, some have got male threads. These are mostly model engineering threads, but some are BA sizes, and you can do these in metric imperial, but these are great for hanging on to small parts if you have to carry out second ops on them. And they're even good for holding parts while you paint them. So you can screw the fitting into the thread there, paint the part, and it protects the thread and stops you getting paint in the threads. However, the thing is, you've got to make sure that part is screwed hard into that threaded mandrel, because some bloke told me many years ago that if you don't grip that part tightly, as soon as the milling cutter hits it, it will spin and ruin the part. And that was good advice, because I never want to do that. Well, there's our 6 slots. They're 2mm wide, 1mm deep. I know, not imperial. Who cares? So I can go ahead now and part that off, and then we'll talk about the gland on the steam chest. And I'm making a bit of a departure from the drawings and the design on that, but I think it's going to be a big improvement. This is the drawing of the valve chest on the Stuart Turner 10H, and this is the valve chest here, and the valve rod comes up through the bottom of this bore here, and it would be sealed with some soft packing in this bore, a threaded bore, and it's compressed by this hex nut. Now they give you some hex bar stock in the kit, and it works. I've used it on engines before, it's fine, but it's not full-size practice. There's a better way of doing it, and it's more, authentic, I guess. I'll show you on the Stuart Turner number 8 what it looks like, and we're going to try to replicate that method of sealing the valve rod on this little engine here. So this is the Stuart Turner number 8 engine. Now it's quite a lot larger than the number 10, and this is the detail that I want to try to replicate on the Stuart Turner number 10. So on this engine here, there's a bronze casting that was supplied in the kit, and it's held over 2 studs, and there are 2 hex nuts that compress that casting into the bore at the end of the steam chest. Now the projection on the end of the steam chest is the same shape as that bronze casting, and although I don't have that feature on the steam chest at the moment, I'm going to try to replicate it. So let me show you what I have in mind, and then we'll see if we can machine up something that looks like that. So here's the steam chest that you saw me make a couple of episodes ago. And what I did was I made these 2 parts off camera. This one's made of bronze, this one's made of cast iron. Now this bronze part here is going to fit inside the bore at the end of the steam chest, and it's been reamed out to suit the valve rod. And the outer diameter of that section there is 1/4 of an inch diameter, and it fits into that bore on the end of the steam chest like so. Now that will have some soft packing inside there to seal the valve rod, but this was previously threaded. So I had to get rid of the threads. I set this up on the 4-jaw chuck, and I used a small carbide boring bar to remove the threads, but that now is a nice sliding fit in there. And in order to compress that, we've got to have 2 studs and a couple of nuts, and that will pull that in tight and compress the packing. Now I'm going to machine the end of this flange here to a sort of a elliptical shape. It's not quite an ellipse, it's close to that, and we'll do that on the CNC mill. And then I'm going to use exactly the same profile on this cast iron part. Now it's been bored out to fit over this end of the steam chest like so, and it's a fairly snug fit at the moment. Now after I've machined that profile, I'll part that off, and that will have the holes drilled in it for the studs, and I'll Loctite this onto the steam chest. So that will give us pretty close approximation of how this was done on a full-size engine. So we'll go over to the CNC mill now, do this part. I've got a tool path worked out, and then we'll run exactly the same tool path on the cast iron part, or very similar. Okay, that looks good. I'm going to drill the holes now for the studs. That's the clearance hole for an 8BA stud, and we'll do the cast iron part now. This cast iron part won't fit in a collet block, so I've just got it sat in the vise in a V-block. I used the probe now to find the centre of that part because we lost our XY position when we swapped out that part. Okay, so that's our XY0. We'll go ahead and run the cast iron tool path now. I just stopped the program. There was meant to be a cleanup pass, like a climb pass at 0.2 millimeters thick, but it's getting very thin on that wall there, and I don't think it matters if this is slightly bigger, but we'll go ahead and drill and tap now with 8BA. Well, there's the part that we just made, the cast iron part, and that goes on the end of the steam chest spigot like that. But I made a bit of a mistake here. This is meant to go the other way around, and these drilled and tapped holes don't go all the way through at the moment. And the reason it's meant to go the other way around is I put a great big chamfer on the inside there, and when we flip it, you can see that now it fits really tightly against the surface of the steam chest, and that's how it's meant to look. But that's okay, I can drill and tap the holes all the way through. There's the bronze part that we just made, and that fits in there, and I reckon that looks tons better than what we had. When I fit this cast iron part, I'll do it with JB weld, and I'll put a nice fillet all the way around the bottom edge there. The JB weld, you can powder coat over that, that's not a problem, and when it's done you won't pick this from a casting. So I reckon that's turned out pretty good. So I'll get this all finished and then I'll show you what it looks like, and then we'll wind up for today. Thought I'd give you a close-up look at some of these parts we've made in today's video, but I also wanted you to see the difference in size between this number 10 engine and the number 8. Now the number 8 has run on air, but it's really a showpiece. It sits in a glass cabinet and I've never run it on steam. But this little number 10 engine I want to set up so it's running on steam from a coal-fired boiler. And I want it to be running something as a load. So it might be a water pump or a generator or something like that. But my reasoning is that these things sound so much better when they're running on steam and they're working against a load. So that's the long-term plan, and making copper, coal-fired boilers is a whole different ball game. But I've done it before, so I think I can manage it with this one here. But let's have a close-up look at what we've done. So here's the lower cylinder assembly. Now later on that will be fitted in between the cylinder and the trunk guide, but I've just left it loose so you can see what I've done. So the piston is fully finished now. I cleaned off the top face of the piston on the rod, and that groove there will be fitted with the soft packing later on. Now the soft packing that I keep talking about is like a string, and it's impregnated with oil and graphite, and you can sort of wind it around that groove there and pack it in tight, and that forms a steam tight seal, and the graphite lubricates the piston and the inside of the cylinder. And we use the same material in here in this gland, and that is the gland nut, or it's really a screw, but I finished that off now and that's screwed in tight into the bottom cover. Later on we'll put the packing in there and that will form the steam tight seal. Okay, there's the finished steam chest cover. I say finished, but this little S isn't actually glued in there yet. It's just held in place with some double-sided tape. And later on, after I've done all the powder coating on the engine, I'll fit that either with some JB Weld or Loctite or something like that. But I think that looks great. It's a huge improvement. I couldn't live with the letter S turned the other way, the way it was. And I think I'm just going to leave that with the natural brass finish and just let it tarnish. I think it'll give it a nice patina when the engine's finished. Okay, here is the part that we just made. This is the gland for the steam chest. Again, this is not finished completely. Later on I'll be gluing that cast iron piece on there with some JB Weld. I'll put a nice fillet around that and then we can powder coat over all of that and it'll just look like one part. And I've made some studs to go through the two holes that we tapped in there, the 8BA holes. You'd think amongst all this stuff you'd be able to find 2 8BA nuts, but apparently not, so I'll have to order some. So when I get those nuts, we'll be able to do a full assembly of that part there. And as you can see, I've got the 3 oilers fitted there now. They'll take a couple of drops of oil each, and that'll just keep everything lubricated, all the reciprocating parts. And of course, the engine itself needs oil, so the piston and cylinder, and that's usually supplied with a displacement lubricator, and it carries drops of oil along with the steam to keep everything lubricated inside. But we'll worry about that later. Now, in the next episode on the Stuart Turner number 10, I'm going to make the eccentric and also the eccentric strap and the rod. Now, I've got something really cool to show you about that. I don't want to tell you about it just yet, but I think you'd be impressed. And I'm going to, again, sort of not use the parts that were supplied with the kit. I'm just going to retrofit a better quality eccentric rod and strap, and also a better quality eccentric, which is going to look more authentic. So that'll be in the next episode on this engine, but the next video I'm releasing is about a couple of side projects that I've been working on in the workshop, and just a short video, but I think you'll appreciate some of the content there. Okay, I'll finish up here now. We saw some interesting birds in the paddock next door this morning, and we saw the kangaroos. The little Joey has grown up now and is much more independent. And at the time I shot the video, it was bucketing down with rain. I feel really sorry for these animals in the rain, but they're evolved to cope with it, and it doesn't seem to bother them too much. So anyway, I'll show you that and enjoy, and I'll see you again in the next video. It's Prezzo. Cheers. There's some pale-headed Rosellas that are feeding on the grass seeds. They look quite comical. You can see them jumping up every now and then to pull the seed heads down. It's still raining here. It's been raining for nearly a week, and everything is absolutely saturated, including the kangaroos.